pull up a web browser with release notes for the upcoming 6.8 release. Hopefully most of you have seen the announcement that we've posted a beta for that. And so I'm going to talk briefly about some of the bigger features that are going to be in this latest release, and then basically invite an open discussion that I'll moderate a little bit on other things people would like to see in the near future, design discussion of anything that we have coming out soon, and other similar conversation for a short while before we split up and go off to less structured interactions and then off to dinner. So let's zoom that in a little bit. Okay. So as noted in the announcement of the beta, there have been over 700 commits since the last major release. Actually, I think that's probably closer to 750 now. About 120 bugs fixed, half of those just in AMPI, the other half spread across the system as a whole. And then a wide range of interesting new features. So some of you who've been here before may remember talks by Łukasz Weslowski on the TRAM framework for aggregating small fixed-size messages into larger messages. We've now automated the use of that framework, so for any entry method taking a small single fixed-size argument, you can just stick the aggregate tag on, and the runtime system will compile and link TRAM for you, and you don't have to do anything beyond that. So we've seen some applications get 20–30% speed up in the phases using that just from that one keyword addition. Another major change that we'll see in the latest release is support for zero-copy send operations. So directly from a buffer that may not be part of a message initially, copied via RDMA to the message buffer on the receiver without a copy into a message on the sender side. And that will be across all of the machine layers when we make the final 6.8 release. So we've added an OpenMP runtime based on the Clang LLVM runtime that was initially open sourced by Intel. This is ongoing work by Sun Myung. So basically, when compiling and linking with this, you can use OpenMP parallel 4 pragmas in your application source code, compile with the usual OpenMP flags, and it will take advantage of idle processors as shared by the Charm runtime in each process. So I see maybe looks of consternation or confusion. I should stop and take brief questions on anything so far.
What platform does that work on? What are the restrictions?
For the OpenMP, I would have to defer to Sun Myung for details, but at least Linux and Macs, it should work fine.
Any compiler?
Should be any compiler, yes. That runtime supports the GCC ABI and the Clang Intel ABI. So it may not work with IBM's XL compiler or Cray's compiler, but that's very edge case. Yeah, Tom.
Could you say a little bit more about how that works with a load balancer? So, there's parameters, how many processors have to be idle before it kicks in?
That's kind of ongoing research of how to optimize exactly that. But generically, it will always at least use the processor that actually reached the OpenMP code. And if other processors come idle while it's still in flight, they can steal work and help out.
But it is sort of like the CK loop construct?
Yes.
Except, I assume, a little more CK loop wasn't particularly automatic. Right?
Yeah, no, it's as automatic as literally Pragma OMP parallel 4.
Okay, terrific.
That's the intended enhancement. So just moving along, we've added a new tracing mode, perf report, that will do some automated end-of-run analysis and make recommendations of what might be limiting performance or scalability. If I recall correctly, this was based on part of the thesis work by Yanhua Sun. So that's something worth trying, probably more so for newer applications rather than those that have been heavily optimized already. But it might still be interesting to see what those, what something like NAMD or Chunga comes out with from a report like that. So we heard about the greedy refine LB strategy during Runux talk. For the sake of interoperability, we've added the ability for Charm++ programs, even when they aren't interoperating with MPI, to define their own main function rather than defining a main char and doing all of the setup in its constructor. So this can make it easier to interface with other libraries or just avoid some of the complexities of Charm's initialization control flow. So GPU manager, I don't think Michael mentioned this in particular, but now rather than being a char group, it's a node group object, which reduces some of the memory footprint overheads and does better scheduling with less contention on the GPU. There are also GPU manager API changes that I don't know the details of too well, but you can harass Michael about those. So malleable jobs that can shrink and expand. This goes along with a scheduler that can cooperate with this. I think there's a plugin for Slurm that can do this, written by Abhishek Gupta several years ago. But otherwise, bug your center sysadmins and your scheduler and resource manager vendors to make this more useful.
So what's the API for that?
Rasmus was asking what the API for that is. It's driven through the CCS interface that's also used by Charm Debug and LiveViz. And we provide a small client library that can send and receive the appropriate commands to the runtime. So it's basically external to the runtime system driving it.
So
Tom?
do any national centers have this incorporated into their queuing
Not
system?
that I know of.
It'd be nice
I'd
to
very much like them to.
just having one experiment with it would be great, right? So we could test it.
Experimental ones we have, but those are not real production schedulers, right? And so the thing is, it's a chicken and egg problem. They don't build it because no one can shrink and expand their jobs. So,
nobody
but
can
I think
shrink.
we have been talking to adaptive computing people, and they're interested. Bill Gay had some interactions with them, and there's quite a bit of interest among job resource manager people, and so we'll see something happen in near future. I think.
We also tested on Stampede. We tested this feature on Stampede by allocating like large number of processors and trying to shrink and expand. So we support that. Just we can't give the extra processors that we don't use back to the scheduler.
And I just wanted to comment that, with NAMD, we can run on pretty much, a range of node counts for a range of times, and we haven't even been able to get like the, range of node
Multiple
counts.
jobs
Yeah, it's
for
like
operation,
we'll take, between, 500 and 700 nodes for, anything over an hour. And I think it just makes the scheduling job harder when you put that much flexibility in.
Yeah. Okay, so for users of reduction operations in Charm, if you find yourself doing logical operations with some sort of custom or integer-based reduction operation, we now have those built in. We can reduce the memory footprint of a lot of operations that are associative and commutative by streaming them. So for the suitable reductions built into the system, that's already enabled. And for user-defined reductions, if that would suit your operation, you can set a flag for it, and the runtime system will then combine results on the fly rather than saving them up and combining them all at once. So we've added a tuple reducer type, so if you find yourself doing multiple reductions back to back, you can combine them instead to do just a single reduction. And we've used that tuple reduction to also implement a summary statistics reducer, which provides, as noted here, count, mean, standard deviation, and I believe also some higher order moments, but I'd have to check. And if not, we should add them. So if you're doing reductions right now to compute, averages and standard deviations, you can use the built-in thing and spare your own code. Yeah, and then there have been some other small improvements and extensions, but I think I'll stop there and we'll open up more general discussion and then we'll break. So, Tim?
I was really hoping that you would mention the very last thing at the bottom of the slide.
Yeah. As noted in the announcement, 6.8 is the last release that will work on ancient compilers. We're going to require full C++11 support from 6.9 onwards.
Yay!
And of course, applications are free to use newer features today. They just can't rely on the same portability that Charm itself has at this point, if they do that.
That's not entirely true. You have to patch charm C in order to be able to use, say, -thid equals C++14. But you can get around that.
Yeah, I believe if Charm is built with that, then it will at least not freak out at it.
Okay.
Because at configure time, we detect what options are needed to get the C++11 feature support. If that's already there, then I don't think we interfere. If we do, then that's a bug and I need to correct it.
All right.
Other broad discussion that people want to bring up?
So related to this, so what is the minimum C++ version for 6.8?
For 6.8, it is C++03 plus 1 or 2 features from 11. Variadic templates, which appeared in GCC 4.3, and lots of other compilers that have been out for like 7 or more years now. And I think R-value references, which also GCC 4.4 and other compilers that have been out for. Basically, we can no longer find machines that don't support this.
Okay, yeah, pretty ancient, okay.
So I want to say that one of the things that I would like our user community to do is to give us feedback on things that they would like to see fixed. And anecdotally, we heard the talk from Rob earlier from Intel. When he started using Charm++, he was one of the people who would just say, "This is how I want to do it in the .ci file. Why is it not working?" And after paying attention, it's like, I want to declare a 2-dimensional read-only array. Why not? So we said, yeah, it should be possible, and we looked at it. It was not, and we fixed it. The reason is what tends to happen to most of us here is that when you first learn Charm++, you kind of stumble onto lots of little annoyances, and you say, oh, well, it doesn't handle this well. I will do it this way. You do your workarounds, and then you never tell us. And so things will never get fixed. So I'm not saying don't use workaround, we'll fix everything, but I'm saying tell us so that we can fix some of those things.
So, gripe?
I don't
Anybody?
mean now, but email us or whatever.
So yeah, if you want to use this session to, gripe at us, we're inviting it. Okay, so it seems the room's pretty quiet, so we should probably wrap up here.